Today we're going to be going over an executive summary of the AWS Next Generation Permission Management video. If you'd like to watch the original video, I have provided a link for that below. Throughout this video, we will go over the permissions management model. Then we are going to go into some permission tools, and then we'll go over the three core parts of the permission model, which includes permission guardrails, least privilege using access analysis, and we will also see how we can use attributes for fine-grained permission. Before we go into the permission model, let's first talk about one key concept, which is who has access to what. The who consists of the workforce users that are operating in AWS, such as your engineers, developers, and also your applications. Then we have the what. This includes things like your buckets or your secrets stored in your secrets manager. So then right in the middle we have our permissions, and this allows us to connect the who and the what together. The AWS permission model is made up of 5 parts, but today we're going to be focusing on the last 3, but let's quickly go over all 5. First, we must separate all of our workloads using multiple accounts by utilizing AWS organizations to be able to group and govern multiple accounts. Then, as we have different workloads, we need to be able to access those accounts by using temporary credentials, and that's where federation comes in. After we have permission guardrails, which helps to prevent access. From there, we have access analysis, which allows us to review and refine permissions on a deeper level. And finally, we have fine-grained permission using attribute-based access control. Now that we went over the AWS permission model, let's talk about some tools that can help you implement that model in AWS. For permission guardrails, here are some of the tools that we can use. Starting off with service control policies, which restricts access for all principals across your accounts. Then we go into the account and we have IAM permission boundaries. And this allows developers to create roles and control that maximum permission of those roles. We also have VPC endpoint policies, which requires that our traffic stay within our VPC. And finally, we have block public access, which blocks existing public access and ensures that new public access is not granted. Now let's take a look at granting access. For this, we have 2 main ways to achieve this, which include using IAM principal policies and resource policies. IAM principal policies are policies that are attached to a principal, such as users or roles, whereas resource policies are policies that are attached to resources, such as S3 buckets or Lambda functions. Now let's take a look at how these policy types all work together. So when it comes down to it, we all know that all access requests have either allow or deny. It's important to note that all access requests start with a deny. So unless there is an allow to all those policies that grant access, the access will be denied. With that being said, all access starts with a deny. But if we want to get an allow, here are some ways to do so. One example is if we are using SCPs, the SCP must allow the request, and there are some other examples below that as well. That was our quick review on permission tools and how they work together. But now let's move on to permission guardrails. First, we want to make sure that we're governing our accounts with AWS organizations. Below is an example of a very small organization that has a management account, and then we have separate organizational units, one being the production and the other being the development. And within those OUs, we also have our different accounts. So that was an example of what an organization might look like. But now let's talk about what we want to be able to do. One of those things is to establish IAM principles across your accounts, organizational units, and your organization as a whole. Some of the most common use cases that companies have are wanting to restrict access to specific regions, prevent IAM principals from deleting common resources, or to restrict service actions for all IAM entities except for specific roles. Below is an example of a service control policy that was used to restrict some powerful service actions. This policy basically says to deny these actions if the principal is not the network admin. So we just covered SCPs, which are basically guardrails across all of your accounts within your organization. And when we drop into the account, we want to use permission boundaries to allow developers to create and manage IAM roles. We want to control the maximum permissions that they are able to grant. Now that we've covered guardrails, let's move on to least privilege and how this can be used in your account. AWS has started to offer tools to help us review access, recognize broad access, and reduce it. Some of the tools that we have are IAM Access Analyzer, which monitors your resources and resource permissions and looks into public cross-account organizational access. Then we have Service and Action Last Access, where we can go to the role and look at the services and actions that were used. And finally, we have Role and Access Key Last Used for general cleanup to help us get rid of accounts not being used. So Access Analyzer looks at your resources continuously to identify public, cross-account, and cross-organizational access. The Access Analyzer relies on automated reasoning to make sure that your analysis has the highest levels of security assurance. So Access Analyzer is all about who can access what, but something that's just as important is reducing access based on who did access what. Some of the ways in which we can do this is by removing unused permissions using SCPs. We can also remove unused principals, services, and actions in IAM. And we can also remove unused S3 actions from IAM policies. Service and action last access allows us to review unused permissions with last access information to remove unused permissions with confidence. Now let's take a look into using attributes for fine-grained permissions to help make things more intuitive and to also facilitate scaling. In this example, we have a set of users that are tagged with certain attributes. And then we have our resources on the other side tagged in the same manner. And then we have a policy in the middle that basically looks to see if the tags match, and if they do, it will grant those permissions. Now let's look at some of the benefits of using ABAC, starting off with the ability to use a permission model that scales with innovation. We are also able to easily understand permissions by matching attributes. We're able to have granular permissions without a permission update for every item. And we're also able to have audit attributes to determine access. Some of the key takeaways to remember are to start with your permission guardrails, to use access analysis to get toward least privilege and reduce broad access, and to leverage attributes for fine-grained permissions. Now, take a minute to review the following review questions. Try them out and see if you can get them right. And in the next slide, I will provide the answers along with the timestamps to review the content.